When you think about robots in factories, the first thing that probably comes to mind is, well, replacing people, right? But what if automation could be something different? What if it wasn't about replacing workers, but about helping them? That's exactly what we're going to dive into today. We've got this amazing case study from Volvo where engineers basically went on a mission to solve a really, really human problem right on the assembly line. So we all know Volvo, right? They build these absolutely massive, tough-as-nails construction machines, total powerhouses. But here's the thing. Building them is just as tough. It's an incredibly demanding process. And at their plant in Bras, Sweden, it was all being done by skilled human hands. I mean, entirely? And that constant physical demand? Well, it was really starting to take a toll on their people. So the factory was facing a couple of big challenges. On one hand, you had productivity issues. Because everything was done by hand, you'd get these bottlenecks that would slow the whole line down. But honestly, the bigger issue, the much more important one, was the ergonomic risk to the workers. Basically, the way some of these jobs were designed was causing serious physical strain. We're talking chronic, repetitive pain in their wrists and backs. All right, so that's the setup. A factory floor full of skilled people, but they were being pushed right to their physical limits every single day. And this really gets to the heart of the trade-off they were facing. Look, having people do the work is great because humans are super flexible. We can adapt, we can solve unexpected problems creatively. But the downside is that physical strain and the fact that work speed can be inconsistent. Now, automation? It's the opposite. It brings amazing consistency and precision, and it can take over those really grueling tasks. The big question for the engineers was, is there a way to get the best of both worlds? Okay, and this is where it gets really interesting. It's kind of like a detective story. The engineers knew they couldn't just throw robots at everything. That would be a disaster. They had to hunt for that one perfect task, the one spot where a robot could make the absolute biggest difference. So where do you even start? Well, they started with a huge wide-angle view. They analyzed the entire factory layout, which, by the way, is broken down into 4 main sections. They had to map out every single process, step by step, just to figure out where to even begin looking. And they looked at a ton of different jobs. I mean, dozens of little sub-assembly tasks. For instance, at one point, they were looking at automating the fender assembly. But that got ruled out, along with a bunch of others. Why? Well, sometimes the job just needed too much human dexterity. Or, the physical risk just wasn't high enough to justify bringing in a whole new automated system. But then they found it. After digging through all that data, their focus just kept narrowing and narrowing until it landed on one small, almost insignificant-looking part that was causing way more trouble than it should have. Its name? The air block. So, you're probably wondering, how did they zero in on that specific part? It wasn't just a lucky guess. They used a really smart 3-step method. First, they analyzed everything happening on the factory floor. Then, they set their priorities. And this is key. Ergonomics was number 1. After that came cost and time. Following that simple checklist led them straight to the perfect candidate for automation. All right, let's zoom in on this air block. What made this one little part the perfect culprit? The answer really lies in the nitty-gritty details of how people had to put it together. And listen to this. This quote from one of the workers on the line, it just says everything. The job wasn't dangerous in the way we usually think of it, like an immediate risk of injury. No, this was a slow burn. It was a chronic problem. The constant twisting, the high-force movements, over and over again. It was just a recipe for long-term wrist pain. So how repetitive are we talking? Well, get this. Each worker had to assemble 12 of these things every single day. That's 12 times a day doing these really forceful tightening motions that put a massive amount of strain on their wrists. So on the left here, you can see the air block as it was assembled by hand. Look at all those different fittings and valves that had to be manually tightened. Now on the right, you see how they slightly redesigned it for the robot. The key thing is all those complex high-torque movements that were so tough on a person's wrist. That's what created the problem. The engineers realized that to automate it, they also had to slightly rethink the part itself. Okay, so they've identified the problem part, they've even redesigned it a bit to make it robot-friendly. So now what? Well, now it's time to find the perfect robotic coworker to actually do the job. And here it is. This is the machine they went with, an ABB IRB 1600. Now, just to be clear, this is a full-blown industrial robot. We are not talking about a small desktop arm here. This is a serious piece of heavy-duty equipment built for pure power and precision. Okay, so you might be thinking, hold on, why such a huge robot? Why not use one of those smaller collaborative robots, a cobot, that are designed to work right alongside people? And that's a great question. The answer comes down to one thing: the tool. The tool needed to apply that much force, that much torque, was an absolute beast. It weighed over 25 kilograms. A normal cobot just couldn't handle that kind of payload. No way. But of course, sticking a massive industrial robot right next to a human worker, that's a huge safety problem, right? Normally, you'd build a giant cage around it. But their solution was way more elegant. They used an advanced laser scanner. This little device basically acts as the robot's eyes, letting it share the workspace with people safely, completely cage-free. And here's the genius of how it works. The scanner creates these invisible safety zones around the robot. If a person steps into the outer zone, the yellow one, the robot immediately slows down to a crawl. And if they get even closer, into that inner red zone, the robot just stops dead in its tracks. It's a really simple but incredibly effective system to keep everyone safe. So we've got the problem, we've got the high-tech solution. What was the result? What did this new partnership between human and robot actually look like when they put it all together? The benefits were huge and they were immediate. First and foremost, the ergonomics got so much better. The wrist pain from that job? Gone. The robot's precision also meant less damage to parts and higher quality overall. And maybe best of all, it freed up those skilled workers to do the more complex stuff, the things that really need a human brain. Plus, it made training new people for that station way, way faster. You know, this whole project is just a perfect example of what true human-robot collaboration should be. It's not about replacing people. Not at all. It's about a partnership where the robot handles the repetitive, the strenuous, the boring stuff, and that elevates the human worker. It lets them focus on what we do best: thinking critically, solving problems, and being creative. And that really leaves us with a pretty cool question to think about, doesn't it? We just saw how a team of engineers completely reimagined one tiny task on a factory floor and made it safer and more efficient for everybody involved. So I'll leave you with this thought. What are the repetitive, strenuous, or just plain annoying tasks in your own life that could be totally transformed by a robotic collaborator?